Today, in this segment, we're going to talk a little bit about the rules of logic, but first I'm just going to reiterate, when you're representing reasoning, you identify and number each premise and each conclusion, labeling each premise as a premise and each conclusion as a conclusion. I'm going through this quickly because we already went over this. You list the premises that most directly lead to a conclusion after writing that conclusion. If a conclusion is a premise in a future argument, or a premise in a current argument is a conclusion of a prior argument, you just list the premises that led to that claim, which is the conclusion of the prior argument and a premise in a new argument. After the claim, you call it a conclusion. And then when it comes to the new conclusion, the future conclusion, you use the number for that claim to say it came partly from that claim. That may be a bit unclear stated in language like that, but as we go through examples, it will become pretty clear what I have in mind. Be sure to add intermediate conclusions and eliminate superfluous claims. So what does it mean to eliminate superfluous claims? It means that any premise, or sorry, I shouldn't say premise, any claim that is listed in your argument but isn't actually leading to a conclusion, isn't necessary to get to a conclusion, is superfluous. Even if it's kind of relevant to the topic, from the point of view of the argument, it's not doing any work. It's not driving to a conclusion and thus should be eliminated from the argument. What does it mean to list intermediate conclusions? It means when you are drawing a conclusion along the way and then using that conclusion as a premise in a future argument for another conclusion, you should make sure you include that intermediate conclusion in your representation of the reasoning. Okay? Symbolizing arguments, use capital letters to stand for atomic declarative sentences. This little symbol here stands for and. You can also use an ampersand, that little squiggly curly thing that you may be familiar with. This little thing stands for or. I prefer this to the ampersand just because it's easier to write and because it's sort of the flip of the or. But if you're typing, the ampersand may be better because it's on your keyboard. And you can just use the letter V for the or, a lowercase v. Okay, this little thing stands for not. You can also use the symbol I showed you before. It goes like that. So it would be like zoop zoop for not. And they get prefixed right before the proposition that you're saying not to. This little arrow stands for if then. You can also use a little horseshoe or any kind of symbols that you're used to. If you're used to some other system, that's fine with me. If I don't know what the symbol is you're using, I'll ask. This thing stands for if P then Q and if Q then P. So implies is like if the thing on this side, then the thing on this side. So if P, then Q, for example. This is just saying the arrow goes in both directions. So if P, then Q, and if Q, then P. We won't use this very much, but it's there if you need it. And parentheses are used to group propositions. The best way to learn how to actually use parentheses to group propositions is by doing it. I can give you some examples as we go forward. So here's some combinations of symbols. So we have an atomic proposition, A, and we'll let it, this sentence, tomatoes are vegetables, we're going to symbolize as A. Now, if we want to say it's not true that tomatoes are vegetables, we can just put the little squiggle in front and say not A. So it's not true that tomatoes are vegetables. If we want to add in some other proposition, we can use the and. We can say tomatoes are fruit, and now we're going to let red peppers are fruit be B. So we'll say tomatoes are fruit and red peppers are fruit. We have an or here to say breads are fruit. We'll say either tomatoes are fruits or breads are fruits. Notice we switched from A being tomatoes or vegetables to A being tomatoes or fruits. In a single argument, you want to always keep the same letter for the same proposition. But in distinct arguments, it doesn't matter. There's no logical connection between a particular symbol and a particular proposition. You just stipulate, I'm going to let A stand for tomatoes or vegetables here. And then later on, we're not in the same argument anymore. We can let A stand for tomatoes or fruit, or we can use P or whatever else. The if then, we can say if tomatoes are not vegetables, then neither are red peppers. Where tomatoes are vegetables is A and red peppers are vegetables is B, we can say it's not the case that tomatoes are vegetables implies it's not the case that red peppers are vegetables. Now we can do it in both directions. If tomatoes are vegetables, then, if tomatoes are fruits, then I say so, and if I say so, then tomatoes are fruits. So you're saying the arrow goes in both directions. The way you write that in English is you say if and only if. So to say tomatoes are fruits, if tomatoes are fruits, then I say so, and if I say so, then tomatoes are fruits is the same as saying tomatoes are fruits if and only if I say so. Now we'll look in a later video at this expression only if so that you can learn how it works. It'll be an important kind of expression because it's important to be able to translate these ordinary language expressions like if or only if into symbols. And then finally, you can use the little line here to indicate a conclusion. So this would say that carrots are not vegetables follows from whatever's above the little line. You don't have to do the little line the way that we're writing things because remember there's going to be brackets over here that will say conclusion and say which numbers it comes from. So you don't have to have this in place, but sometimes it's easier to see what's going on if you have these occasionally whenever you're drawing a conclusion. Okay, now using parentheses, I'm not going to fault you for incorrect use of parentheses when you do your representations, but I want you to be able to use them because it can help you think clearly, so I'm just going to show you some examples. So if I say not A or B and I don't have any parentheses, what I mean is either A is false or B is true. So the not does not extend out to the B. This negation here doesn't extend to the B. So it's either A is false or B is true. Similarly, here we have either A is true or B is false. Now, what happens if I put a not with parentheses? Then the not applies to the entire formula inside the parentheses. So here what I'm saying is it's not the case that either of these is true. So put another way, I'm saying neither of these is true. Put another way, I'm saying both are false. So not paren A or B paren is equivalent to not A and not B. The not kind of applies to both, and then you get an and there. How about this? Not A and B. So not paren A and B paren. Then what I'm saying is it's not the case that both of these are true. So it's not the case that both are true. What does it mean that it's not the case that both are true? It means that at least one of them is false. It's not saying both are necessarily false. It's saying at least one of them is false. So you can read it like this. Either A is false, B is false, or both is false. That's what this formula says. At least one of them is false. How about this? Not A, then B. Well, the not just applies to the A when there's no paren. So it's saying if A is false, then B is true. What if I have not and then a paren? Then what I'm saying is it's not the case that if A is true, then B is true. So I'm saying it's not the case that A implies B, or A doesn't imply B. How about not A if and only if B? Then I'm saying it's not the case that A being, let me back up. Then I'm saying the fact that A is false or the fact that A is not true implies B, and the fact that B is true implies that A is false. So this is like saying A and B just can't go together. How about this one? Not A if and only if B. Then what I'm saying is it's not the case that A holds if and only if B holds. To put it another way, it's not the case that each of these implies the other. At least one of them doesn't imply the other. Okay, I know I went through that quickly. Usually I would sort of talk it through in class and ask you if you have questions. Without questions, I'm not sure where to give further explanation, so I just suggest rewinding and listening again if you want to sort of master parenthesis use. But again, I won't be marking you down for failing to use the parentheses. The main reason to learn to use them is because it will help you think through problems more clearly and get to the right answers. Okay, so we're going to stop there and we'll start next time by looking at the rules.